Hi everyone and welcome to this video about domain and range of functions. Before we begin this video, please remember to like and subscribe if you enjoy the video. If you have any questions about the content that I've covered, please leave those down in the comments section below. If you would like a video on another maths topic, feel free to leave that in the comments section as well. The domain and range of functions can be thought of as the input and the output of our functions. Looking at this one-to-one mapping here, we can see that the function must be f of x equals x plus 2. The set of numbers on the left is what we describe as the domain. The set of numbers on the right is the range. We can write this in set notation, where the domain would be written like this, as a set of numbers, and the range would be written as a set of numbers like this. Let's look at our first example question. We're given the domain, or the inputs, for this function f of x. The way to find the range then is to just put in every single one of my inputs. So these numbers that I've worked out here will form the range for this question. Not all questions are going to give you a domain or a range as a set. Most often we'll be given a set of inequalities. For example, here the domain is said to be x is greater than or equal to 2. In this case, we can't just put in every single one of the numbers in my domain into our function to work out which output numbers come out. So the way we do this is to put in the boundary numbers to give them a test. Let's take the boundary number of x equals 2. So we're going to have 4 as the output for when my input is 2. Let's then consider the next number along. In this case, I'm going to pick 3. We can see that the numbers are going to gradually get bigger as I increase the value of x. No number that I work out from this function is going to be smaller than 4. So I can summarize that the range of g of x, and in this case I'm going to write g of x in an inequality to describe the range, is greater than or equal to 4. Here I have the graph of y equals 2 over 3x plus 1. In the x direction, it only goes from minus 6 to 3. In other words, we've limited the range of values that x can have. In the case of a function, this is the domain. The y direction then is the output of my function. In other words, the y direction shows me the range. For this question, we can see that the maximum value of y is 3 and the minimum value of y is minus 3. So the range of this function is between minus 3 and 3. Let's take a look at these examples. For function number a, we have f of x equals 2 minus 3x, and we're given the domain all real numbers. So we're going to have to try and figure out what the boundary of this range is going to be. Well, in this case, we know that a function of this form is going to be a straight line on a graph. Now, if I'm allowed all real numbers as my input, that means I'm allowed any number in the x direction. For a straight line on a graph, that means the output can be all the numbers in the y direction. So the range is simply all real numbers. For part b, we have the function g of x equals x squared for all real numbers. In this case, we might think that, like the previous question, we might be able to get all real numbers as our output. However, this is a quadratic graph, and the boundary occurs when we have the value x equals 0. For x equals 0, we would have 0 squared is 0. That is our output. But for any value below 0, let's try minus 1 squared, that would be a positive value of 1. Any negative number that I place into this function as my input is going to be outputted as a positive number. That means that I'm only ever going to get out numbers greater than or equal to 0. For the next question, we have the function h of x equals 1 over x plus 1. And we're given the domain that x is greater than or equal to 0. We know our boundary number is going to be 0, so let's put that in, and we get the output of 1 over 1, which is 1. Let's increase the value of x and see what happens. Let's take x equals 1, so 1 over 1 plus 1 is a half. We can see that as we increase the value for x, we're going to get smaller and smaller numbers. Now it's important to remember we can think of infinity as one of the boundaries of our input. So let's see what happens when we put an extraordinarily big number into this function. Well, we can see that the bottom of the function is going to tend towards infinity. it's going to be much, much bigger than the one on top. Now, if we divide 1 by an incredibly large number, it's going to approach 0. So the range of this function is going to be 1 on one side, and our range has to be smaller than 1, and it's going to approach 0 but never equal 0, so we can place that there. And that's going to be the range for this function here. Sometimes we're going to come across functions that require some extra values to be excluded from the domain. This is normally the case when they lead to impossible operations. So the division by 0 and the square root of a negative number are the things we have to look out for. Let's look at f of x. We can see that any value of x is going to be allowed apart from the value of 0. Any other value will give me a real fraction, but I know I'm not allowed to divide by 0. For g of x, I can see that again I've got a fraction and I don't want the bottom to be equal to 0. In this case then, I must exclude the value x equals 2. When x equals 2, I can see the bottom of that fraction will be 0, so giving us an impossible operation, therefore we must exclude it if we want it to be a function. For these two functions, we can see that we have a square root. Remember, we cannot square root a negative number. So here, our value of x must always be greater than or equal to 0 in order to ensure no negative numbers get into our square root. For g of x, we can see that x minus 2 in the square root must be greater than or equal to 0. So we can start off by writing this as x minus 2 must be greater than or equal to 0, and solving this inequality in order to find that x must be greater than or equal to 2. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comments section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.